I would like to thank also Matusanka and the NESLab team for the invitation. And it's also my first time in Dublin, so it was a nice opportunity to present and come here. Today, I will talk about this, let's say, this security and trust from a network management and orchestration. So everything will be depending on network management and orchestration. So we will try to build, let's say, topics around this aspect. So, I am working at the Services Networks Research Unit at CTTC. Actually, this is the summary of the talk for today. So it will be divided into three. So first, I will let's say try to give some kind of a data engineering aspects for the secure network management orchestration, which is more or less the advanced version of data science. Then somehow try to give some motivation on the blockchain, and especially in terms of this identity management, self-sovereign identity, how we can utilize it in different use cases, scenarios. And then we will try to go finally to this kind of new quantum aspects, PQC, and somehow how we can integrate this quantum key distribution and other kind of developments into the network management aspects. So let's give an overview of the network service management. So yeah, as you may know, this new kind of applications, especially in the 6G, is going to emerge. This holographic type communication, teledriving, this tactile internet, these are all new kind of applications. And somehow, as you can observe, these kind of applications, these distributed computing functionalities in a network environment. So, and also the levels of the service requirements are getting elevated every year, with hundreds of operations at the same time needs to be managed. So traditional way of this kind of service management in kind of human-centric obviously are not feasible, and there should be some optimal solutions that somehow need to be advanced. So for this kind of let's say in the standards, when you go to the network management, this is like a reference architecture proposed by the ETSI, termed as ETSI Mano. So on the right, you have this management and orchestration functionalities. You have this, let's say, NFV orchestrator, virtual network function managers, and this virtualized infrastructure manager that are, let's say, managing the underlying infrastructure. And you have this VNF manager, which is trying to manage the virtual network functions. So this is more or less the reference architecture. So I think most of the talks will be based on this reference architecture and these derivations that somehow we can utilize in terms of security and trust. So I mean, when you look at like a landscape of the tools, you can also see many open source tools, right? So for example, in the, let's say, service orchestrator domain, you can have this open source Mano, Cloudify, and other kinds of tools. Of course, for the virtual infrastructure managers, you have this OpenStack, Kubernetes. And when you go to the real infrastructure, you can have this open source Open5JS, OpenAir interface, and of course the NFVI of Intel. So this is kind of the landscape. I mean, in terms of the let's say NFV management and orchestration. So what this figure shows is kind of a variation of one of the projects that we were working, which is called 5Growth, which is somehow advanced version of this ETSI Mano stack. So here you can see two administrative domains, and each administrative domain is managed by its own Mano stack, which is divided into 3 layers. You have this vertical slicer, which is taking some kind of requirements from the verticals. You have the service orchestrator, which is kind of the brain, and you have this resource orchestrator and service orchestrator, and taking some inputs from the infrastructure, trying to, let's say, link the VNFs together. And you have this resource layer, which is somehow the layer that somehow does this kind of connections on the infrastructure. So here, what we are trying to advance, just the regular mono stack, is to add this kind of, let's say, machine learning, AI/ML, this blockchain networks, and somehow SSI, or this kind of identity management techniques on top of this kind of mono layer to somehow add kind of like security and kind of trust. So yeah, when we look at the service orchestration, like secure orchestration, so you could have many choices, right? So first of all, you could have many players in the systems. So, for example, you have these vertical service providers that are providing some services, and somehow you have this infrastructure provider as another player. You can have cloud service providers, multiple cloud service providers, and you can have the mobile operator, which is managing the infrastructure. And on top of it, as you may also guess, we can also add these kind of additional layers with the blockchains, and also you also need to integrate with the regulators and authorities environment. So when we look at this kind of, let's say, regular orchestrators, so there could be many choices where somehow you need to solve this interaction between multiple parties, and somehow also this with the quantum computers coming into effect. You need to somehow organize this communication between these multiple players accordingly. So first, I will go with the machine learning part. I think I don't have much time, so I will try to somehow make it like a global picture, because most of the things that are done in machine learning falls into one of the modules here. So actually, this is like a data engineering thing, so it is kind of much higher, let's say, vision than the data science with the, like the regular AI/ML based, let's say, security models. So somehow this is advancing it with the connection modules, data ingestion modules, storage modules, and visualization. And on top of it, somehow you need to manage the data. So this kind of pipeline could be used for this kind of security information and event management systems. And so one example of this, again, is somehow this kind of mono layer is somehow integrated into, let's say, AI machine learning platform, and with kind of like, I would say you could try to use this kind of federated learning, other kind of models to detect intrusions or any kind of attacks with the help of the machine learning model that is somehow embedded into the mono stack. So the second part is related to the blockchain aspects. So how can we use this in the machine management and orchestration? So as I described before, so when you are trying to, let's say, deploy some services, so somehow there could be multiple players here, right? So these services may be deployed by an operator, but operators somehow may need some help from cloud service providers. They can have their own orchestration domains, so these kind of interactions should be secure and also trustable. So in this kind of scenario, blockchain could be helpful. So to establish this trust between, let's say, multiple, this is an example for, let's say, interaction between the multiple players. So if you want to deploy some service as a vertical service provider, you can design a permission blockchain-based network service, and you can have this approval phase from the legal authority or responsible ministry. You can commit, let's say, transactions of the, let's say, management logs, and somehow you can commit it into the blockchain with the help of the regulation authority. So I will not go too much detail, but this is kind of like a stacks that you can build as trust on top of when you are trying to install the network service. So another aspect is this self-sovereign identity. So you can somehow use these kind of techniques as to establish this digital identity. So as you may know, I saw some posters also with the SSI. So you have this kind of an owner of an ID. Somehow the issuer issues this ID to the holder, and holder is somehow showing this ID to the verifier. But in addition to the regular self-sovereign identity model, you can also embed this blockchain. So all these interactions between these kind of entities could be go through the blockchain network. So you can have this kind of, let's say, structure. So issuer can sign the credentials to the blockchain. Holder can countersign it and put it into in the blockchain network. And somehow when holder presents its, let's say, credentials to the verifier, verifier can verify it on the blockchain network. So what you can do on top of this is to somehow, let's say, we say that there are multiple stakeholders. So for example, cloud service providers or any other service provider can somehow hold this kind of identity, and they can present this identity to a monostack, and monostack can interact with the blockchain to verify the ownership of this identity. So what you can see is that somehow you can give these identities, distributed identities to the multiple stakeholders, and somehow you can verify this kind of identity over the blockchain, and somehow also you can automate it with the different blockchain networks. Somehow you can do this identity management system and somehow regular blockchain network to automate it, the process. So what you can do, some kind of use cases of this kind of SSI could be somehow, for example, if you are, I mean, you don't need to do it for the persons or these kind of things. So you can also do it for the, let's say, entities, for example, routers. So for example, in this example, if you are trying to establish autonomous systems, so there is this regular connection. If there is new connection arises, somehow you need to authenticate this, let's say, border router to the system. Otherwise, if it is not authenticated appropriately, it can inject faulty lines and you cannot be able to reach your services. So this could be a big problem. But then somehow, if you can somehow give this kind of identity and its capabilities to the router and import list and router list, and this somehow with the help of this kind of blockchain and SSI, you can somehow establish secure connections. So you can identify the border router that wants to connect to your system. So this comes to the new dimension. Maybe, I mean, this is a little bit different than the regular, let's say, management, control, and data plane. So now we are coming to kind of like an identity plane. You can say something like this. So every time, I mean, as you know, in the zero trust architecture, so you need to somehow authenticate, verify, authenticate all the time. So this comes into the play when somehow these kind of devices, when they are trying to establish connections, you can go to the identity plane and somehow verify yourself to identify your cases every time you interact with another device. So the last aspect is related to this kind of PQC, QKD-enabled networks. I mean, this is already discussed. Post-quantum cryptography is taking effect due to the lack of, let's say, security quality of the public key infrastructure with RSA, the Feynman and elliptic curves. So somehow this is just showing a different aspect. So you can, when you want to design this kind of post-quantum technology in a new network environment, so you need to consider communication aspects, computation aspects, and networking aspects. So you can have different dimensions from device perspective and networking perspective. So from the networking perspective, you can take actions from the, let's say, computation domain, and you can give the requirements to the implementation. And from the device perspective, somehow these protocols needs to be say, elevated to, I mean, it's not just TLS, right? So you will have different protocols in the communication. So this kind of protocol advancements should be taken into care and design perspective, and somehow you need to devise this kind of public key system to do implementation. So another aspect in when you apply to this kind of orchestration into the post-quantum era could be somehow, let's say, which kind of, let's say, I will say, post-quantum method or computation method should I choose? There could be different computation methods because this kind of encryption protocols are higher order, so you need to have these multiplications in an efficient manner. So it is a kind of a scenario in a vehicular VTX environment. So this is kind of a dynamic environment, and somehow you need to choose, let's say, which computation method you would like to do, because somehow maybe you may want to use multiple cores in the system to do, depending on your load. So these kind of aspects could be helpful when you are trying to do this kind of computation orchestration in the orchestration domain. So I don't know, I will not go to detail, but there is different kind of computation methods like Karatsuba and Tom Cook, and you can try to accelerate your system depending on your choice. So of course, blockchain is also has kind of an attack could be attacked in the post-quantum era. So when we look at a regular blockchain, a private blockchain, let's say, process. So first you have this approval, then you have this transaction phase, and finally you have this block commit phase. So in the regular blockchain, so this approval and transaction phase are relying on these public keys. So this could be the place where there could be attacks, and this is the hashing phase, which is somehow considered to be outside the PQC environment. So here, for example, you can try to, let's say, build your system with the PQC to somehow enhance the blockchain network when you are trying to commit blocks. Yeah, this is just showing an example of how these kind of interactions could be done in a, let's say, network service orchestration. So you can have like automatic guided vehicles, and you can somehow control it with a joystick. And this kind of, let's say, network connections could be established with let's say, monostack. And somehow with the help of, let's say, not only one person could be deploying this service, but there could be cloud services. For example, some of them could provide this cloud environment core network or cloud network, and some of them could be providing radio. So that this kind of trust could be established with these PQC-based blockchain networks also. So finally, this is the kind of a way to proceed when we are trying to integrate this kind of, let's say, QKD networks, let's say, blockchain-based identity layers into like a regular application-oriented system. So you can have this kind of like a quantum layer in between where you can exchange the keys, and you can have this control layer on top of it. You can have this management layer, which is regular management, and key management systems, which is interacting, of course, with the QQD layer. And on top of it, you have this identity layer, and of course, interacting with the secure keys. And the applications are using this, let's say, information from the bottom layers to have this secure connection at the top. Yeah, I think this was it so I went over 3 dimensions. Of course, this is, I mean, from our perspective, but there could be many dimensions. So blockchain-enabled management and orchestration, AI enhanced, and this kind of QQD and PQC-based management and orchestration layer. Yeah, this was a brief review. Thanks a lot.